Okay, so let's talk about Chapter 3, Section 3, and deal with decimal fractions. So in this section, we're going to talk about how to convert fractions to decimal numbers, solve practical problems involving decimal numbers. And you know that decimal numbers are simply fractions that are written in a different form. Because it is usually easier to work with decimals than with fractions, it is useful to be able to convert a fraction to its decimal equivalent. A terminating decimal is a decimal that comes to an end. So we're going to talk about some examples of that. So an example of a fraction that converts to a terminating decimal is 5/8. So if we take 8 and we ask ourselves how many times it goes into 5, this is a good example. So we've added our decimal. We've talked about how to divide decimal. We've talked about how to divide decimals before. So they follow the process, but when your remainder is 0, you end up having a terminating decimal because it comes to an end. It doesn't have a part that repeats like some of the other ones do. If the denominator of the fraction is a power of 10 or 100 or 1000, then conversion to decimal form is even easier. Simply move the decimal point to the left as many places as there are zeros in the power of 10. So we've got 11 over 1000, and you can see that we have 1, 2, 3 zeros, and so we needed to have 3 decimal places. So we've got 1, 2, 3 numbers that are in the decimal place. Short fractions are used so often in practical work that it is important for you to know their decimal equivalents. The table on the next slide, or right below, shows the decimal equivalents for fractions that are used frequently in trades. Those with denominators of 2, 4, 8, 16, 32, and 64. Those are sometimes referred to as short fractions. Although it would be difficult to memorize the entire table, it would be helpful for a trades worker to learn the decimal equivalents for the fractions that occur most often in his or her job. And so they've got some of these listed here. 1/16 is 0.0625, 1/8 is 0.125. Now, like they were saying, it would be impossible for you to learn all of them, but if it's something that you use a lot, it would be good to know the decimal equivalent to that fraction. To find the closest fractional equivalent to 0.741 or 741 thousandths inches from our table, we notice that 741 thousandths lies between 47 over 64 and 3/4. Okay, let's talk about this real quick. So we've got 0.74, okay, and if you look at this one, we've got 0.73 and 0.75, and so we know that it's in between these two. This is a better graphic of that. So we've got 0.73 right here, 0.75, 0.74 would be somewhere in the middle of those two things. Now, suppose you need to approximate 0.741 inches with a ruler that measures only to the nearest 1/16 of an inch. To find the closest fractional equivalent on this ruler, we'll need to consider only those values in the table with denominators of 2, 4, 8, and 16 because that's all they use on a ruler. So if we look at So I'm going to slide up here to our ruler that's got some decimal equivalents up here. And if we look at 0.741 is the decimal that we're trying to locate. Okay, I'm at 0.625 here. If I go to the next one, I'm at 0.68. So I'm still not at 0.74, but if I jump up to the next one, I'm at 0.75. So I know that 11/16 is 0.6875. If I don't know that, and I don't have the table in front of me, I can do 11 divided by 16, and it will tell me that. The next one is 3/4, which we know is 0.75. And so we would also be able to divide that out and be able to see that. And so I know that this 0.741 is in between these two estimates, 11/16 and 3/4. Okay, so which one is it going to be closer to? 0.741. Well, if we add 0.009, we're at 0.75. 0.6875, you can see that that is a lot farther away from 0.741 than 0.75 is. And so when we come down here, we can, and this is what this statement is saying, it's easy to see by inspection that 0.741 is closer to 0.75 or 3/4 than it is to 0.6875 or 11/16. So 3/4 inches would be the closest fractional equivalent to 0.741 if we had to get something really close. In practical applications, such as finding the best size wrench for a certain size bolt, a minimal amount of clearance is required. In these cases, we would always choose the higher of the two options rather than the closer one, because if it was too small, it wouldn't fit at all, right? So you'd want to pick the one that was bigger always, not necessarily the one that was closer when you're talking about those bolts and wrenches. Repeating decimal. So a repeating decimal is different than a terminating decimal because a terminating decimal comes to an end. It has a remainder of 0, but a repeating decimal does not come to an end. Here's an example. If you did 1 divided by 3 in your calculator, you're going to get this. 0.33333. It goes on forever with no with a pattern, right? And a lot of times you'll see it written 0.3 with a line over it because that indicates that it is repeating. And also, so do the dots at the end. If you see the dots at the end, that same thing is, it keeps going forever. That's a repeating decimal. So here's an example of a repeating decimal. They want us to convert 3/11ths to decimal form. So they've taken 11 and they've taken 3, pardon me, and looked at how many times 11 would go into 3, and they're coming up with this, right? And we still have this remainder of 3, so we could add another 0 and bring down that 0, which would make this next number be a 2. And it would just keep on going, 2, 7, 2, 7, okay? And so this is an example of a repeating decimal. We could also write this 0.27 with a line over it. You would only put the line over the part that's repeating. Okay, and now this is what this next part's talking about, bar notation. And so 1/3 can be written 0.3 with a line over it. 0.3/11 can be written 0.27 with the bar over it because it repeats. So how do we convert 11/30ths to decimal form? We're going to see how many times 30 will go into 11, and we get to the bottom here and we have a remainder of 20, and if you'll look, we still have every time we had a remainder of 20, and we kept bringing down zeros, and so we would do the next number and we would keep getting 6. Well, if you'll look at this one close, the only thing that keeps repeating is the 6. The 6 keeps going on forever, but the 3 doesn't, so that's why they just put the line over the 6. How do we round decimal fractions? Well, if we want to round to 1 decimal place, the nearest tenth, they've given us this example right here. It was 0.1538, and it keeps going, right? So if I'm rounding to the nearest tenth, I would stop here, look next door. Since it's 5 or bigger, I would want to round up. So you stop at the tenths place, look next door, and see if you need to round up. If I want to go to the hundredths place, well, this is the tenth, this is the hundredths. Well, the next number is a 3, so you're going to leave it, it's not 5 or bigger, so we're going to leave it 0.15. If I want to round to the thousandths place, I'm going to look next door, and that's going to be 0.154 because 8 is 5 or bigger, so it made us round the 3 up to a 4. So if we want to add 2 5/8 plus 3.28, well, the first thing we want to do is convert 2 5/8 to decimal form. Okay, so you could do that using your calculator if you want to. You would just do 2 plus, and then in parentheses, or use the fraction bar, 5 divided by 8, and it would give you this number. So then we would have our 2.625 plus 3, and remember you want to line up your decimals when you're adding decimals. Okay, so that's how we're coming up with 5.905. So first thing we want to do is convert it to a decimal form if it's in fraction form. Okay, so it says finally round this answer to agree with the number of decimal digits in the original decimal number. Well, the smallest number to start out with, the only decimal number we had was this, and so we would want to round just to 2 decimal places. So our 5.905, we would want to stop with the 0, look next door, the 5 would make the 0 round up to a 1. And so that's how they're getting this answer. They rounded to 2 decimal places because in our original problem we only had 2 decimal places. In water and wastewater treatment formulas, flow rates must be expressed in units of millions of gallons per day. However, in real-world situations, measurements of flow are frequently reported in gallons per day. To convert gallons per day to millions of gallons per day, simply divide by 1 million. So if we had 28,500 gallons per day, to find millions of gallons per day, we would say 28,500 divided by a million. Well, because there's 6 zeros in a million, we would just need to take this this number right here, and move our decimal place 6 times to get our answer. And so right now we've got 28,500. If we wanted to, cheat, that would be 1, 2, 3, 4, 5. They said move it 6 times because we had 6 zeros, so we would have to put a 0 there as to hold our spot. Now, you really don't need these 2 zeros on the end, and that's why they didn't include them there. Okay, that's the end of 3.3, and that's the end of chapter 3. So we're going to be moving on to chapter 4.